Welcome. In this video, we are going to determine whether the mean value theorem can be applied. Then we're going to find any values, all values, which satisfy the conclusion of the mean value theorem. And so here I'm given a function f of x equals x cubed minus x squared minus 5x plus 6. And the interval we're given is between -2 and 3. So this tells us the interval along the x-axis. So the first thing we need to do is determine whether or not this function is differentiable and continuous on the interval. And so what we're doing here is we're determining whether the mean value theorem can be applied. That's what we're doing here. Well, yes, it is. Since f is a polynomial, it is continuous and differentiable everywhere. Okay, so now that that's done, let's find the average rate of change on the interval. And to help, I'm going to start numbering this. This was step 1. We had to determine if we could apply the mean value theorem. Next, let's find the average rate of change. That is, let's compute. Let's compute the average rate of change, so the average on the given interval. So the average rate of change on this interval is equal to f of 3 minus f of -2 over 3 minus 2. So popping a 3 in for all the x's here will provide us with an output of 9, and then putting in a -2 for all the x's here will provide us an output of +4. And this is over. Oh, there's a little typo right here. I did 3 minus 2. Don't do that. It's 3 minus -2. There we are. And this is over 5. So 5 over 5. So 1. This tells me that the average rate of change on the interval is 1. All right, so now what we need to do is set our derivative equal to the average. So we need to find the derivative, then set that equal to the average rate of change. All right, so the first derivative of our function is equal to 3x squared minus 2x minus 5. And now our average rate of change was 1. So I'm going to let this whole derivative here equal 1, which is our average rate of change. Subtracting 1 from both sides, we end up with 3x squared minus 2x minus 6 equals 0. And now this, you can use the quadratic formula. So x equals -2 plus or minus the square root of -2 squared minus 4 times 3 times -6 over 2 times 3. And this works out to be 2 plus or minus the square root of 76 over 6, which simplifies to 2 plus minus, not 4, 2 root 19 over 6. All right, so we have two answers for x. Our two answers are x equals 1/3 plus root 19 over 3. That's one of them. And our other value is 1/3 minus root 19 over 3. Now, those of you, especially in a first-year calculus course, my students in particular, I did kind of gloss over the algebra and arithmetic here. So if this did not make sense to you, how I got from this step to this step to this step to here, then pause the video and work this out manually until you understand how to get these values yourself. All right, so all the values that satisfy the mean value theorem are the two here below. Now, before I end my video, I'd like to show you what this means geometrically using GeoGebra Online. So as you can see here, I have GeoGebra up. You can just go to geogebra.org. geogebra.org, or just search for GeoGebra on your favorite search engine. So I'm going to go to this 3x3 grid, and I prefer to use Classic. So here we are on GeoGebra Classic. And the first thing I'm going to do is graph f of x. F of x is equal to x cubed minus x squared minus 5x plus 6. And let's go ahead and change the viewing window so I can really just focus in on what's going on between -2 and 3. So here is -2 comma f of -2 right there, the lower value of our interval. And then, of course, we have 3 comma f of 3. There's that other point. And let's take a look at the line between them. So when I say the average rate of change, that's another way of saying the slope of this secant line here. And what is the slope of this line? It's 1. And to see that without actually doing any mental math, you can go to settings, algebra, and changes to y equals mx plus b form. And there you go. The slope of this secant line between this point here at -2, 4 and this point at 3, 9 is 1. So now let's take a look at the two values we found. So I'm going to say little c underscore 1. So c1 is equal to 1/3 plus the square root of 19 over 3. There we are. And c underscore 2 is equal to 1/3 minus the square root of 19 over 3. So now let's look at 2 points. So c underscore 1, then you want to hit your right arrow, type in a comma, f of c underscore 1. There it is, there's c1. And now c2, let's do the same thing. c underscore 2, right arrow, comma, f of c underscore 2. There's that other point. And GeoGebra has this cool thing it can do. If I go here to this line menu, I can find tangent. So I'm going to select that, select the point here. And there it is. There's one tangent line, has a slope of 1. And I'm going to do the same thing for the other value we found. And there, this one is, it also has a slope of 1. So as you can see, these lines are all parallel. And on our interval from -2 to 3, let me hide most everything except our interval. There we are. So basically on our interval, we found 2 points that share, that is, they enjoy the same slope as the secant line through the endpoints of the interval. Hopefully you found parts of this video at least a little bit helpful.